Yellowstone Supervolcano Inflating. Volcano is rising with molten rock at record rate according to a study. This is by University of Utah on phys.org. Digital elevation map of Yellowstone and Grand Teton National Parks. Color data changes. Global positioning system finds and receives the information. Satellite measurements are made. A University of Utah study of the data indicates the giant Yellowstone supervolcano is one of the 21 supervolcanoes of our Earth. They said is rising upwards faster than ever observed. The red arrows pointing up represent uplift of the Yellowstone caldera or volcanic crater, while the downward red arrows show sinking of the land near Norris Geyser Basin, and the black arrows indicate lateral or horizontal ground movement. And this is by Wu Lung Chang, University of Utah. And let's see what they found. So the Yellowstone supervolcano rose at a record rate since mid-2004, likely because a Los Angeles-sized pancake-shaped blob of molten rock was injected 6 miles beneath the slumbering giant. This is according to University of Utah scientists and what they reported in the journal Science magazine. They said there is no evidence of an imminent volcanic eruption or hydrothermal explosion. That's the bottom line, says seismologist Robert B. Smith. He was the lead author of the study, professor of geophysics at the University of Utah. He says a lot of calderas, that is, giant volcanic craters worldwide, go up and down over decades, of course, without erupting, he says. The upward movement of the Yellowstone caldera floor, almost 7 centimeters or 3 inches per year for the past 3 years, is more than 3 times greater than ever observed since such measurements began in 1923. Now, our best evidence, he said, is that the crustal magma chamber is filling with molten rock. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So the magma chamber is filling with molten rock. This is according to Smith. He says, but we have no idea how long this process goes on before there either is an eruption or an inflow of molten rock stops and the caldera deflates again, he said. The magma chamber beneath Yellowstone National Park is not a chamber of molten rock, but a spongy-like body with molten rock between areas of hot, solid rocks. Chang, the study's first author, says, to say if there will be a magma molten rock eruption or hydrothermal hot water eruption, we need more independent data. Calderas such as Yellowstone, California's Long Valley caldera, the site of the Mammoth Lake ski area, or Italy's Campi Flegrei near Naples, huff upward and huff downward repeatedly for decades to tens of thousands of years without catastrophic eruptions. Smith and Chang conducted the study with University of Utah geophysics doctorate students Jamie Farrell and Christine Puskas, and with geophysicist Charles Wicks of the U.S. Geological Survey, Menlo Park, California. Yellowstone is North America's largest volcanic field. It has 60% of the world's geysers and over 10,000 hydrothermal areas, and it is produced by a hotspot, a gigantic plume of hot molten rock that begins at least 400 miles beneath the Earth's surface and rises to 30 miles underground, where it widens to about 300 miles across. And there, the blobs of magma or molten rock occasionally break off from the top of the plume and rise farther up, resupplying the magma chamber beneath the Yellowstone caldera. Previous research indicates the magma chamber begins about 5 miles beneath Yellowstone and extends down at a depth of at least 10 miles. The heat powers Yellowstone's geysers and hot springs fumaroles, the world's largest hydrothermal field. As Earth's crust moved southwest over the Yellowstone hotspot during the past 16.5 million years, it produced more than 140 cataclysmic explosions, 140 in 16.5 million years. Cataclysmic explosions known as caldera eruptions, So that's a lot, isn't it? 140? The largest but rarest volcanic eruptions known. Remnants of ancient calderas reveal the eruptions began at the Oregon-Idaho-Nevada border some 16.5 million years ago. Then they moved progressively northeast across what is now the Snake River Plain. The hotspot arrived under Yellowstone area sometime after about 4 million years ago, producing gargantuan eruptions there 2 million years ago, 1.3 million years ago, and 642,000 years ago. These eruptions were 2,500 times, 280, and 1,000 times bigger, respectively, than the 1980 eruption of Mount St. Helens. The eruptions covered as much as half the continental United States, with inches to feet of volcanic ash. The most recent gigantic eruption created the 40-mile by 25-mile oval-shaped Yellowstone caldera. The caldera walls have eroded away in many areas, although they remain visible in the northwest portion of the park. Yellowstone Lake sits roughly half inside, half outside the eroded caldera. Many smaller volcanic eruptions occurred at Yellowstone between and since the three big blasts, mostly 70,000 years ago, and another 80 eruptions since then. 80. Smaller steam and hot water explosions have been more frequent and more recent. Measuring a volcano getting pumped up. In a new study, the scientists measured uplift of the yellow caldera from July 2004 to 2006 with two techniques. 12 global positioning systems, GPS, ground stations that receive timed signals from satellites, making it possible to measure the ground uplift precisely. The European Space Agency Envisat satellite, which bounces radar waves off the Yellowstone caldera floor, another way to measure elevation change. The measurements show that from mid-2004 through 2006, the Yellowstone caldera floor rose up as far as 7 centimeters per year. That's almost 3 inches, 2.8 inches every year, and by a total of 7 inches during a 30-month period, Chang says. The uplift is still going on today, but at a little slower rate, says Smith, adding there is no way to know when this will stop. Smith says the fastest rate of uplift previously observed at Yellowstone was about 0.8 inches per year, that's 2 centimeters, between 1976 and 1985. So it's obviously going much faster. Now he says that Yellowstone's recent upward motion may seem small, but it's twice as fast as the average rate of horizontal movement along California's San Andreas Fault. The current uplift is faster than ever observed at Yellowstone, but it may not be the fastest ever, since humans weren't around for its 3 supervolcanic eruptions. Chang and Smith and colleagues conducted computer simulations to determine what changes in shape of the underground magma chamber best explain this recent uplift. The simulations or the modeling suggest the molten rock injected since mid-2004 is a nearly horizontal slab known to geologists as a sill that rests upon 6 miles, 10 kilometers, beneath Yellowstone National Park. This slab sits within and near the top of the pre-existing magma chamber, which resembles 2 anvil-shaped blobs expanding upward from a common base. Smith describes the slab's computer-simulated shape as a kind of like a mattress, about 38 miles long, 12 miles wide, but only tens or hundreds of yards thick. In reality, he believes the slab resembles a large spongy pancake formed as molten rock injected from below, spreading out near the top of the magma chamber. The pancake of molten rock has an area of about 463 square miles, compared with 469 square miles of the city of Los Angeles. Smith and colleagues believe steam and hot water contribute to uplift of the Yellowstone caldera, particularly during some previous episodes, but evidence indicates molten rock is responsible for most of this current uplift. Chang says that when rising molten rock reaches the top of the magma chamber, it starts to crystallize and solidify, releasing hot water and gases, pressuring the magma chamber. But gases and steam compress more easily than molten rock, so much greater volumes would be required to explain the volcano's inflation, the researchers say. Also, large volumes of steam and hot water usually are no deeper than 2 miles, so they are unlikely to be inflating the magma chamber 6 miles underground, Smith says. Now, what about the ups and downs at Yellowstone? Yellowstone is breathing, it's heaving up and down. Conventional surveying of Yellowstone began in 1923. Measurements show the caldera floor rose 40 inches during 1923 to 1984, and then fell 8 inches from 1985 to 1995. GPS data shows the Yellowstone caldera floor sank 4.4 inches during 1987 to 1995, and from 1995 to 2000, the caldera rose again, but the uplift was greatest, 3 inches at Norris Geyser Basin, just outside the caldera's northwest rim. During the 2000-2003 period, the northwest area rose another 1.4 inches, but the caldera floor itself sank about 1.1 inches. The trend continued through the first half of 2004, and then in July 2004, the caldera floor began its rapid rate of uplift, following 3 months later by sinking of the Norris area that continued until mid-2006. Smith believes that uplift of the middle of the caldera decreased pressure within rocks along the edges of the giant crater. He says so it allowed fluids to flow into the area of increased porosity, end quote. And that in turn triggered small earthquakes along the edge of the pancake of magma. The amount of hot water flowing out of the deflated Norris area is much smaller than the volume of magma injected beneath the caldera, Smith said. This was from University of Utah on phys.org. Please leave your comments and thank you for your support.